Hi, welcome to Make 2 Explore. In this video, we will see how to make OpenThread border router. For that, we will use Raspberry Pi and Nordic's nRF52840 dongle. So let's get started. So first, let me explain what is Thread border router and why it is important. Then, we will see about its open source implementation, that is OTBR, OpenThread border router. So we know that Thread is one of the mesh networking protocol used in smart home for connecting IoT devices. It is just like Wi-Fi, Bluetooth, Zigbee, Z-Wave, etc. If you want to learn more about what is Thread, Matter, and their importance in modern smart home and IoT systems, we recommend you to check out our previous videos. We have the whole playlist about these all topics. So you can see in this diagram, as we know in a modern smart home, protocols like Wi-Fi, Thread, Zigbee, and Z-Wave quietly handle the networking, while Matter as an universal application layer protocol ties it all together, creating a smart home system. Matter's main goal is to ensure interoperability. So these all other protocols can have their separate individual mesh networks like Wi-Fi network, Z-Wave network, Zigbee network, etc., with IoT devices supporting only those specific protocols. So you can see these all smart IoT devices works on Thread protocol forms this Thread network. This devices may include lights, sensors, thermostats, switches, sockets, or outlets, etc. And in order to connect all these devices to main smart home network, we need a device, or we can say bridge, which is called as a Thread border router. It acts like a bridge between your Thread-based smart home devices, which form their own secure mesh network, and the rest of your home network or the internet. In simple terms, it lets your Thread devices talk to your phone, Wi-Fi devices, or cloud services. So what is OpenThread? OpenThread is an open source implementation of the Thread networking protocol. And we know that Thread is a low-power, secure, and robust mesh networking protocol for connecting smart home and IoT devices. We have discussed about Thread protocol and its relation with Matter in detail in our previous video. For more information, you can check that out. Google Nest has released OpenThread to make the technology used in Nest products more broadly available to developers to accelerate the development of products for the connected home. So, who supports OpenThread? OpenThread is supported by many leading and reputed tech companies, making it a trusted and future-proof choice for IoT development. It was originally developed by Google Nest and is now open-sourced and maintained by Google, with active contributions from major industry players like Qualcomm, Nordic Semiconductor, NXP, Silicon Labs, Texas Instruments, and ARM. This strong backing ensures that OpenThread stays reliable, secure, and up-to-date, while aligning with industry standards like Thread and Matter, which are shaping the future of connected smart devices. OpenThread border router, OTBR, is a device, in this case, our Raspberry Pi, that acts as a bridge between the Thread network and a Wi-Fi or Ethernet network. It allows devices on your Wi-Fi network to communicate with devices on your Thread network. OTBR allows you to manage the Thread network and its devices, providing essential services like network discovery, commissioning, and routing for seamless interoperability between different wireless standards in a smart home environment. Okay, so this was all about theory part of OpenThread border router. Now let's move on towards actual implementation, means practical. For this practical, we will need two main hardware components: Raspberry Pi and Nordic's nRF52840 dongle. We used Raspberry Pi 4 Model B+. And this is a Nordic's nRF52840 dongle. Raspberry Pi as an OTBR or OpenThread border router, and Nordic's nRF52840 dongle as an OpenThread radio coprocessor, the RCP unit. The RPi acts as the central brain, running the OpenThread border router software that connects the low-power Thread network to your home's Wi-Fi or Ethernet network. It handles the higher-level network logic, such as IP routing and network management. On the other hand, the OpenThread radio coprocessor is a physical radio, typically a USB dongle, that provides the actual 802.15.4 wireless communication. It handles the low-level radio transmissions, transmitting and receiving thread packets under the command of the software on a Raspberry Pi, and is essential for the physical existence of the thread network itself. Thread radio coprocessor needed for OTBR to talk to thread network. In practical, we have to carry out two steps. First, we will flash the NRF dongle with an OpenThread RCP firmware. Then in step 2, we will install and set up OTBR, OpenThread border router on Raspberry Pi via command line using the official OTBR GitHub repository. So the first step in our practical is preparing an RCP USB dongle. You can do this with two ways. Either you can build your own RCP firmware for this dongle, using the steps they have given on the OpenThread's website, or you can simply download and flash the precompiled binary. We will use second method, which is easiest one. We have uploaded precompiled binary or hex file of RCP firmware on our GitHub repository. You can download it. Let me show you. Here's the one. So you can see the RCP firmware folder here. In this folder, you will get firmware files. So you have to download the complete repository to get them. Let's download it. For that, you have to download full repository from here. Okay, now let's see how to flash this firmware file into NRF dongle. For that, you will need one more software. That is NRF Connect for desktop. Download and install Nordic Semiconductor's NRF Connect for desktop application, which includes the necessary programmer tool for flashing the dongle. You will get that software on this Nordic website. This is the link. We will share it in video description as well as on documentation on GitHub repository. Here, download this according to your host operating system, like Windows, Linux, or Mac OS. As we are running Windows OS, we have already downloaded and installed NRF Connect for desktop on our system. Let me show you. So here is the NRF Connect for desktop application running on Windows OS. You can see this application already included with the programmer tool, which we will be using for flashing the dongle. Now let's connect the NRF dongle and flash the RCP firmware file. But before that, let me tell you one important step which you have to do to put the dongle into DFU mode, that is programming mode. So this is the Nordic's NRF 52840 USB dongle. Beside the main chip, there are two buttons. This white button is SW1 user button. You can see this. And beside that, there is reset button. About this reset button, note that the button does not face up. You will have to push it from the outside in towards the USB connector, like this. Please note, to enter into DFU mode, we have to press this reset button, not this big white user button. So, to enter into DFU mode, first plug in the NRF dongle to your computer's USB port. Like this. Okay. Then, we have to press reset button once. Let me show you. Like this. Then, to identify and verify that we have successfully entered into DFU mode, watch this LED. When the dongle enters DFU mode, the red LED will begin to pulse or fade in and out. Like this. Okay. Then, dongle will appear as a new device in the NRF Connect desktop programmer app, as ready to be flashed. Let me show you. Like this. Okay. Then, browse the RCP firmware hex file and start flashing process. Just follow along and see how we do it. That's it. Completed successfully. We have now flashed and prepared the NRF dongle as an RCP device. Now next task is to prepare the Raspberry Pi. So if you want to replicate this, use similar hardware setup and just follow along with us. We will be using a headless setup without a desktop monitor, as it's not required for this project. However, if you do have a full desktop setup with a monitor, you can still follow along and adapt the instructions to your environment. To prepare the Raspberry Pi, we will use Raspberry Pi Imager software. This software helps you to flash operating system on SD card. As I said here, on the website of Raspberry Pi. The Raspberry Pi Imager is the quick and easy way to install Raspberry Pi OS and other operating systems to a micro SD card, ready to use with your Raspberry Pi. You just have to download and install Raspberry Pi Imager on a computer. You can download it from here as per your OS variant. We have already downloaded it and installed on our Windows machine. Let me show you. So here is the Raspberry Pi Imager software. Let's use this SD card reader. Insert the micro SD card into SD card reader. It is recommended that you should use at least 32 gigabytes of high-speed SD card. It will act as your primary storage of OS. Then insert the card reader into your computer or laptop and run Raspberry Pi Imager. First step is choosing the Raspberry Pi device. So here we will select Raspberry Pi 4. You can select as per your Raspberry Pi hardware variant, like Pi 3, Pi 4, or Pi 5, etc. Okay, then next step is to selecting the OS. We're going to use Legacy 64-bit OS with Lite version. Since, for this experiment, we don't need desktop OS, so we will use the Lite variant. Here, we also tried latest Bookworm 32-bit and 64-bit, but didn't work for us. So we decided to go with 64-bit Legacy Lite variant. You will get that in Raspberry Pi Imager, Legacy operating systems. Select this one. After you select the OS, then next step is to choose the device, that is SD card drive, on which you want to flash that OS. And that will be our recently inserted SD card, right? Please select this carefully, since if you select incorrect storage drive here, your data on that drive will get lost, as Raspberry Pi Imager will format that drive while flashing OS onto it. Okay, now once these 3 steps completed, click Next. You will see new window of OS customization settings. These are very important settings. Here you can set hostname, username, and password for your Raspberry Pi. Then, in wireless LAN settings, you should enter your Wi-Fi credentials. That is your Wi-Fi SSID and password. Since we are using headless setup, it is mandatory. Then you can set other settings like your time zone and country. Then on Next tab, there is very important setting you have to set. That is, enable the SSH. SSH allows users to log into remote machines, execute commands, and manage applications as if they were physically present at the computer. Since we're going to access our Raspberry Pi with it, with secure remote access. Once you do all these settings, save them, and go ahead with flashing the OS. This flashing process will take some time. Wait to process to complete. Okay, so OS has been flashed onto SD card. Now remove the SD card, insert into your Pi, and power it on. Just remember to connect the NRF dongle to any USB 2.0 port of your Raspberry Pi. Once the Raspberry Pi is powered on, it will get connected to our Wi-Fi router whose credentials we have given during OS flashing process. To log into our Raspberry Pi remotely via SSH, we need to know its IP address. We will get that in wireless routers DHCP client list. You can also use any IP scanner app. So this is the IP of our Raspberry Pi. You may have different IP address. It will depend on your network settings. So copy this IP. Then, use any remote terminal software like PuTTY or Terraterm, etc., and log into Raspberry Pi via SSH. Okay, now we have logged into our Raspberry Pi. Let's execute the setup command to install the border router software. Just follow along. On our GitHub repository, you will find detailed guide for how to install OTBR, OpenThread border router, on a Raspberry Pi. Then, we have also shared another guide, which explains how to build your own RCP firmware for the nRF52840 dongle. You can follow this if you want to build your own RCP firmware. Here on the repository, we have also shared pre-built binary of RCP firmware. You can download it and use it. And for testing, we have also given a guide for testing a thread network with OTBR and ESP32 devices. This guide outlines the steps to set up and test a thread network using a Raspberry Pi running OpenThread border router, OTBR, with two ESP32-based thread end devices, ESP32C6 and ESP32H2, and Amazon Echo as a smart home controller. So we will cover this in next session. Let's first set up the OTBR on Raspberry Pi. So first, let me show you the system information. You can run these commands on your Raspberry Pi to verify hardware and OS details. Now, there are only few steps remaining. We have already completed the first step, that is, flashing the RCP firmware to nRF52840 dongle. Let's move on towards next step. Step 2. Set up OpenThread border router. Just follow along. First, let's install Git. Then, clone the OTBR repository. Run the bootstrap command. Please note, here we have enabled WebGUI and NAT64 service for IPv4 capability. This command will set up the OTBR on our Raspberry Pi. Now, to verify that OTBR has been successfully installed on our Pi, let's access the WebGUI portal. So as they said here, the WebGUI in the OpenThread border router is a browser-based graphical interface that allows users to manage and monitor the thread network. It is accessible by visiting the Raspberry Pi's IP address. So if your Pi's IP is 192.168.0.100, then you'll get that WebGUI page at this address on port 8080. Let's check out for our setup. If your WebGUI and the OpenThread border router is not running, then you have to do some troubleshooting. We have given some steps to fix this issue. You can follow these steps. Let me show you. This WebGUI provides a convenient way to view network status, connected devices, and perform basic operations like network creation or reset, without needing to use command line tools. It's especially useful for users who prefer visual interaction over terminal commands. Okay, so in this way, we have installed and set up the OTBR, the OpenThread border router, on Raspberry Pi. In next session, we will see its testing with ESP32-based thread and devices. Please stay tuned.